First power talk we got here today is Kyle Konis from the University of Southern California. He's going to share a bit about training the future workforce of BEM professionals. So I'll hand it over to Kyle.
Okay, thank you. It's a pleasure to be included in this event. This is my about longtime simulator and first-time attendee to CalBEM. So this is a power talk. I'm happy to chat with any of you and all of you more about these topics, which are lessons learned from my own efforts to teach building energy modeling in the graduate building science program at USC. For the past several years, I've been the director of the Master of Building Science program, and we have building performance modeling, not surprisingly, integrated into our core required courses as well as the master's thesis. Often students choose that as a topic. So when I talk externally about this, and in a school of architecture, I emphasize the point that the standard of care in architecture, engineering, and construction is shifting, and it's shifting towards evidence-based design as an expectation. And so performance modeling is a core piece of that. And that means that as design teams are being selected, they're being expected to at least demonstrate the capability to deliver model-based predictions of building energy performance. And this example here from NREL is a good example of that happening in practice. What I think separates this talk a little bit from a lot of the earlier discussion is the stage of design that is critical in architecture, which is in the earliest stages of design. That's when performance feedback is critical, because that's when the decision making is taking place. So we have a lot of examples today of taking a kind of a cooked outcome and running it through analysis to quantify its performance. But ultimately then, there's very little that can be done in terms of retrofits or interventions to get it to where it could be in terms of its potential for performance. And I think another aspect here that's evolving is this expectation for verification. So taking a score as an example and thinking about how could we gain confidence in the applicability of these scores by verifying them against some kinds of measured performance outcomes, either in individual buildings or across the building stock. This is a grab bag of lessons learned from teaching. I think reading through all of these individually would be rather tedious. Interestingly, a lot of these came up during the working group 2, which I was pleased to participate in. These are known, I think, for the most part. I'll just emphasize that we often discount the kinds of human factors, performance indicators entirely in the modeling process. And when they are included, they tend to be very crude assumptions for either what people are actually doing in the buildings or what their expectations are for indoor environmental factors. So that's an area where we can deliver a lot more value in terms of being able to model and demonstrate the end user conditions in buildings. And one example of that would be in terms of assessing heat risk in the built environment. Okay, so I'll end on one of my, I think as I put together this lightning talk or this power talk, what would I land on in terms of this grab bag of lessons learned? I think the key is to somehow convey to students, again, this talk is meant to be about training the future workforce, that there is joy in this process. And this, again, is we're trying to sell or to convince a population of students at this point that building performance modeling is something to consider really committing a significant portion of their adult life to. We need to make the case that this is a joyous process and there's real value behind it. And certainly there are pro-environmental benefits of doing this work, but the actual execution of the work on a day-to-day basis can be enjoyable. I think that's a piece that we should work hard on. And then I'll just wrap it up there. We are working at USC to develop a kind of an educational catalyst at the K through 12 level. So if you're interested in hearing more about that or helping to support that, please reach out. And I'll wrap it up there. Thank you.
Awesome, thank you. All right, I'd like to invite Rezvan Ziazi from Energy Solutions up, who's going to share a bit about mutual support of BEM and CalNEXT projects.
Good afternoon, everyone. I'm a senior research analyst with Energy Solution, and I want to thank CalBEM for giving me the opportunity to talk briefly about how BEM tools and CalNEXT projects can mutually support each other. So significant amount of research has been done on emerging and new technologies through CalNEXT. And as I mentioned, there is kind of like an interaction between BEM tools and these CalNEXT projects. Some of the research needs building energy modeling, and also some of the CalNEXT projects directly or indirectly are or having like goals to enhance or improve the existing building energy modeling tools. So my goal here is to go through some of these CalNEXT projects in the next few minutes and basically describe them. So for this purpose, I actually selected 4 active or completed CalNEXT projects that I'm gonna go through very briefly to see how they kind of support BEM tools, or BEM tools actually support them. So the first one is energy saving and cost analysis for duct ceilings in commercial buildings. In a building with forced air heating and cooling system, duct leakage is actually a common problem. So the goal for this project was to evaluate the duct systems in the non-residential buildings, and also gathering some data in order to develop a measure package. So as you can see, there is kind of like mutual connection between BEM tools and this specific project. So in order to assess the impacts of duct ceilings on HVAC performance, they needed, the project team needs basically BEM tools. However, some of like existing BEM tools have some limitations in modeling and simulating these duct systems. So the gathered data through this project can be used to enhance and also resolve those specific limitations. Another example, as it's shown in the basically title, is kind of like investigating the possibility of combining heat recovery chillers and air-to-water heat pumps into one measure package. Also, the CalNEXT team is actually interested in identifying the use cases that these two technologies are inappropriately basically applied in buildings. So building energy modeling and simulation tools can support the process of or the research in this area. The next project is modeling CO2 refrigeration systems. So transcritical CO2 refrigerants are emerging low GWP refrigerants that are usually used in supermarkets and grocery stores refrigeration systems. And however, current building energy modeling tools have some limitations in simulating these specific refrigerants. So the idea of this CalNEXT project was to collect the data of 2 supermarkets in order to find the correlation between the store condition and some other factors with the refrigerant load, and then basically create a tool off of OpenStudio in order to kind of resolve those limitations of existing BEM tools. And finally, this project is actually completed is the market characterization of mobile and manufactured housings. So the basically goal for this research was technical finding technical and market barriers in electrifying the mobile and manufactured housings. So the project team gathered some data about geographic, climate, or even behavior, and also building characteristics data such as age, equipment, appliances, baselines for these buildings. And they used BEM tools in order to create building energy model of some typical mobile and manufactured housing in different California climate zone in order to kind of develop a measure package to electrify these types of buildings. So with that being said, I want to thank you for your time and attention, and I want to encourage you, if you have any research ideas, please go through the CalNEXT website and submit your ideas. Thank you so much.
All right, next up we have Liam Buckley, who's approaching on my left here from IES. He's going to share a bit about compliance software updates for IESV 2024.
Thanks, Neil. Liam from IES, everybody. So for those unaware, we have two relationships with the Energy Commission in terms of compliance software. Venn diagram showing on the left, we're a certified energy code compliance software tool. That gives you three models, the first one being an actual design model, which is what is used as an approved solar assessment. There are two more derivatives, a Title 24 proposed design and then a Title 24 standard design, also known as a baseline model. So I'm giving you 4 updates associated to IESV 2024, and the first one is a parametric simulation feature. The main highlights are it's a free integrated update, it's fully automated, and there are speed and data enhancements. There are a number of input categories and a number of permutation options associated to each input. Currently, the outputs include energy, cost, and carbon, but there can be more. I just want to give you a quick example how you might use the tool. It's a simple tabular interface where you can add permutations. Just as a quick example, if you wish to add weather files to look at resiliency, you can compare your building and see how it performs in the years 2030, 2050, 2080, and more if you wish. If you wish to perform a solar shading study, on the left-hand side you have no shading, in the center you have horizontal shading, and on the right-hand side you have twice the depth of horizontal shading, and you can see the impact on the facade. Next would be, for example, solar PV. So you can go from no PV panels to 50% of the roof area to 100% of the roof area. Next, we look at envelope. So it's thermodynamically, obviously, looking at construction assemblies and materials, but it also gives you access to controls. So if you want to check operable controls for natural ventilation, the tool can do that parametrically too. Next one over will be lighting/daylighting, so simple lighting power density. But of course, if architecture is changing, it's re-simulating the daylight performance for each parametric permutation. And finally, HVAC. This one will allow you access to set points, be it for heating, cooling, relative humidity, any airside system, any plant side system. Because it's a files-based system, you get access to anything and everything in the Apache HVAC tool, be it a COP or a performance curve or anything that is available to you. So when you click on Simulate, the performance is between 4 and 13 times faster than Apache is traditionally. There are a number of reasons for that. Simultaneous simulations for each parameter, parallel processing in the back end. Basically what you get on the output is live interactive HTML reports. For example, here there's a parallel coordinate chart. You can check that on our own website and play around with it if you wish, where you can do active filtering from 1,000 permutations to figure out what inputs are required to get you close to your target output. One large AHJ did reach out and ask us to add locations once we launched the tool. So that could be used in California for large-scale prototypical analysis, or you could indeed use it for ASHRAE climate zone analysis. Second enhancement is associated to heat pumps. So here I'm showing 6 water-to-water heat pumps, auxiliary heating source, providing heat to airside coils and also a DHW loop. The enhancement is for each of the water-to-water heat pumps. Each type of them can now get a choice of what the heat source or heat sink is. So here's an example that it's either pulling or rejecting heat to a heat transfer loop, which might include solar hot water, a water-to-water heat exchanger, a cooling tower, and you can put any type of equipment on that ambient loop to act as a source or sink. The third enhancement is associated to a new performance compliance path. I'm sure many of you are familiar, but the practitioner industry in the US has been pivoting away from the stable baseline model associated to PRM. So we introduced the ASHRAE ECB method, Energy Cost Budget method. That brings with it Workflow Navigator, automation in terms of the budget, building and compliance reports. That tool was approved just over a month ago by the Florida Building Commission. And finally, for solar assessment tools, so we opened a discussion with the Energy Commission 2 weeks ago about what would be possible for the 2028 code. We really enjoy the discussion. You can see there's about 7 or 8 competitor vendors up on the CEC's website that are currently used for solar assessment. So it's really nice to be engaged as a stakeholder to figure out what could be possible with the tools that are out there for the 2028 code. And I'm hoping that type of stakeholder engagement trickles over to other parts of the Energy Commission. Thank you.
All right, thank you, Liam. That was excellent power talk there. All right, Jared Landsman of E3 is up next on why should we care about existing buildings?
All right. Thanks, everyone. So for those of you in this room who know me, you probably know me as the person who wreaked havoc on the TDV factors for the 2025 code cycle. I'm excited to not at all talk about that right now, and instead talk about another topic that will get everybody angry. So I think we know there's some very lofty goals for the whole country, and in particular the state, to hit our GHG reduction targets. And to hit these targets, we're obviously going to need to rely pretty heavily on the building sector, preaching to the choir here. However, to date, there has not been a ton of progress in residential and commercial buildings. So, excited that obviously California is ahead of the pack on zero carbon new construction, and I think we all know this. There's obviously been a huge effort, in particular by people in this room, in advancing our codes and standards for Title 24 for new construction. Excited to say that under the 2025 code cycle, all 16 climate zones will have residential heat pump heating and residential heat pump water heating as part of the baseline. And then for non-residential sector, some of these baselines will, but by the 2028 code cycle, we are expecting pretty much all heat pump heating and water heating baselines. So we did a great job. We did it. Round of applause for the room. Unfortunately, new construction really isn't the largest opportunity for emissions reduction anymore in the building sector. I did some quick math, happy to tell people after my presentation how I put this together, but looking at emissions coming from the California building stock. And so what we can see is that looking at new construction for this next code cycle, 2026 to 2028, that'll account for approximately 1% of annual emissions from California's building stock. Now you might be saying, Jared, obviously all the buildings that are constructed in 3 years are not going to make a difference when we talk about all the buildings that have been built to date. So instead, why don't we look at the actual emissions from an individual building? So a building built under this new Title 24 will generate less than 50% of the emissions of a household that already exists. And a new commercial building will generate approximately 1/3 of the emissions than a typical building that already exists, a commercial building. So what I'm ultimately saying here is that the existing code is getting so stringent that we're getting to the point where additional emissions reduction with future code cycles is going to get smaller and smaller and smaller. Now that's a dangerous statement for me to say since I'm under contract to continue working on Title 24. So this is frustrating. So ultimately, I think the message that I've come here to tell this group is that if we truly want to achieve sector-wide emissions reduction across buildings, we need to be focusing not only on new construction, but also on existing buildings. There's great tools that are now available for us. A big shout out to NREL, who has developed the ResStock and ComStock data set, which is a collection of over 1 million open studio energy simulation models that capture the US building stock. There are folks here from NREL today, so if you have more questions about ComStock and ResStock, go find them. But the reason this is so great is because it is very detailed, bottoms up. You can look at things hourly by end use. It's all been calibrated to ground truth data and also stochastic occupant behavior. And it is really a game changer for the industry. This is great. So we can do really cool things now, like forecast hourly building loads under different electrification futures. We can do things like look at a whole portfolio of emissions reduction strategies to evaluate new programs and new policies at a regional level or a state level. And so really, ultimately, I have a call to action for the California energy modeling community, which is to develop new programs and policies that will help address the existing building stock decarbonization. So obviously there's things that are already happening. If you haven't heard about zero emissions or zero NOx appliance standards, go look them up. These are going to basically mandate all electric gas heating and water heating appliances for both new and electric construction, starting in the Bay Area and the South Coast, and then potentially in the whole state if CARB passes this. Building performance standards, which are going to be talked about at the next panel. And there's lots of other interesting ways that could potentially address this issue through rate design, some interesting funding and financing programs, and some other just sort of innovative potential strategies. So happy to discuss this further offline, and thank you for your time.
All right, thank you, Jared. Next up, we have Greg Collins of Zero Envy, who is going to share a bit about the future of BEM reporting.
Thanks. Mini break from slides. I'm going to tell you a little story. It's about an energy modeler that I know. She's excellent at energy modeling. She can synthesize complex architectural and MEP design information and build accurate and detailed energy models and provide effective insights. On the last project, she used modeling to help the architect design a complex facade system, help lighting designers optimize daylight dimming controls and application, helped HVAC engineers leverage heat rejected from the chiller plant to provide most of the space heating needs. Throughout the project, her model and results were reviewed by a technical leader at her company. Thank goodness her colleague was also an energy modeler. As it is, it takes 3 to 4 hours for a decent review of an energy model and results for each milestone. She can't imagine how many days it would take somebody to review a model without having the model itself and expertise with the software. Once the design phase was complete, she used the model to obtain a building permit by showing compliance with Title 24 code, receive a LEED Green Building certification, and then earn energy efficiency rebates with the local utility. This is the worst part of her job. It's bad enough that each of these organizations require a separate model, but they also require model inputs and results data to be reported in completely different ways. One of them automatically generates a report, which is kind of nice. However, each of the 97 pages of this report had to be placed on a drawing sheet. That was 13 total sheets. She's never received any comments, so maybe she nails it every time, or maybe all that hard work and paper goes to waste. LEED, on the other hand, definitely reviews the models. She's had a project go through once without comments, but usually she receives a few questions about substantiating cooling savings or unmet load hours falling outside of an expected range, something like that. They also require a ton of model data that has to get entered into this big spreadsheet with 1 million data tables in weird formats that always seems to break. One of her other modeler friends said that there's an even worse spreadsheet that other states are starting to use for 90.1 modeling. She's glad she hasn't had to deal with that one yet. I don't know about all of you, but I can definitely see why she's frustrated by so much manual work in a job that focuses on technology, data analytics, and efficiency. I'm an energy modeler myself, and I've done a bit of software development in the BEM space. I've been thinking about this nonstop, and I even had a dream about it the other night. In my dream, I had this superpower where I could read the minds of every person in charge of making decisions for all the energy modeling-based codes, the review entities, the modeling tool developers. I don't have enough time to explain what they're all thinking. Ask me later. But what's more important is what the future reporting platform could do. So Sam is an energy modeler and just finished his final design model for a project. It's time to submit the model and results for compliance, certification, and utility incentives. So he clicks the publish button in his software. The software writes the model inputs and results data in a standard format and uploads it to the cloud. He logs into the BEM data platform where he reviews the model and results with his customized dashboard tools. Everything looks good, so he sends the published model over to his supervisor, Maria, for her to review. Maria views the model with her own data viewer tools and runs it through the company's QA/QC checker. It passes both, and she approves the model. Sam then generates a graphical summary report to send to his client. The client's a little bit old school, so he still likes to have a report instead of dashboards. Then Sam issues the model to the 3 organizations, Building Department, Certification Office, and the Utility Incentive Program for their respective reviews. Each of these departments run their own automated checks and human reviews on the model and then approve it. After that, they submit the model to a portfolio database where they can analyze projects in bulk. This is a big help understanding the effectiveness of the code and informing future updates and just general good data to have. Since they're on the same platform as Sam, he can see the status progress through these stages and is happy to see it get fully approved. If you're interested in helping turn this dream into reality, please come talk to me later. I'm about to start a project for IBEPSA USA and the Department of Energy to develop a vision, engage with key stakeholders, and then build a roadmap for the future of BEM compliance reporting automation. Thanks.
All right, thanks, Greg. All right, last up is RJ from the CEC, who's going to share a bit about the 2024-2025 CBECC update for everybody.
All right, afternoon, everyone. I'm RJ Wichert. I'm part of the CEC team responsible for developing the public CBECC software. And I'm going to try to give you a really quick update on kind of where we're at and kind of recap the journey we've had this code cycle. So 22 has been a big code cycle for us. We're looking at doing our 9th release this winter. Maybe we can make that an even 10. I don't know. We'll see for the 22 cycle. We've had a number of 2025 research versions, and we're looking at having more of those early next year as we get into the thick of developing the 25 software. Some of the recent additions we've had over the, recent additions through this code cycle, just to kind of recap, we reformatted multifamily into the formerly CBECC COM software. Now we dropped the COM. It's multifamily high-end, low-res, and non-res. We've added PV and battery to CBECC. And dealt with a lot of complications there that we've been working on ironing out. And one of the big lifts, we had the California Utility Allowance Calculator in CBECC. Formerly, that was an Access spreadsheet. So now that's in CBECC. And a number of other things like air-to-weather heat pumps that we've added in the end of 19 and into the early 22 code cycle. And here, where we're at. Kind of in between 22 and 25. We've got 5 software options for non-res and single family, including one alternative engine. So pretty excited about the variety of options out there for compliance software. And like I was saying, we're kind of about to jump into 2025 code development, or 2025 software development. We just had the ACMs posted a couple weeks ago, and so now we're really digging into developing that 1.0 version, which we have to get done by middle of next year. And so that ninth release that I was mentioning, the 3.2, we're looking at adding a number of things, including a VRF crosswalk to translate the old test years developed under the 2014, converting those to converting the new 2023 years to the old so they work with our curves. We're adding pump refrigerant economizers to CBECC. And then we have computer room efficiency updates, going from the old year inputs, which aren't usable for those systems, to net sensible COP. And then for the QAC, we're actually porting QAC over to CBECC Res for single family use. And then both softwares, we have an update to the J13 credit, QAC rate updates, and lots of bug fixes. And where are we going? So like I was saying, our high priority right now is the 2025 software update. We're looking at possibly 1 to 2 Energy Plus upgrades in the next couple months before that 1.0 version. We're investigating a new air-to-water heat pump object versus the one that we got in at the end of 2019 code cycle. And as you guys probably are aware, we have a new multi-zone HVAC system requirements, and we're looking at covering at least the new standard design of the package fan or parallel fan power box. And then we have VRF, 4-pipe fan coil, and possibly others that we'll add before the code goes into effect. We also have a VCHP, a third iteration of the VCHP credit that we're investigating. And then along with all the other 2025 code updates that we have to get done by next year. We've also got changes in the project management. We're moving to GitHub for our code and tickets. And we've got a support line streamlining, which hopefully has been noticeable. We're now tracking in GitHub. And as we talked about in the working group 1 earlier, we're looking at streamlining third-party software testing and updating that to reflect the current software. And always I like to throw in a little resources slide here. Just make sure you're on the subscription so you get updates to the software. Check out the blueprint, and then a couple links to our software web pages. And happy to answer questions separately. Yeah. Thanks, everyone.